In this video, I'm going to introduce the idea of polynomials and some vocabulary that we use with polynomials, and then we're going to work on adding polynomials together. Of course, when I say polynomial addition, that really means addition and subtraction, because subtraction can always be expressed as addition. In that way, they're just pretty much the same concept. So first, let's talk about what a polynomial is. You can kind of think of a polynomial as a nice math expression. We've been looking at a bunch of different kinds of math expressions. Polynomials are going to be an expression where we're not going to divide by any variables, so we won't have variables in our denominators, and we won't have any crazy exponents like a negative exponent. In other words, a polynomial is an algebraic expression with only whole number exponents on the variables. Let me give you an example of something that is a polynomial. Negative 2x to the fifth minus 4xy plus 6. So our exponents there that are on the variables, we have a 5, and then there's a 1 on the x and a 1 on the y. So those are only whole numbers, exponents on the variables. If we had something like x to the negative 2 plus 6x, this is not a polynomial because it has a negative exponent attached to a variable. Also, something like 2y over x squared is not a polynomial because we're dividing by an exponent, we're dividing by a variable, and that's the same thing as having a negative exponent. So that is not going to be a polynomial either. Now that we've seen some examples of what polynomials are, there are some polynomials that have special names. Let's look at those now. The first one is monomial. And a monomial is a polynomial that has one term. An example of a monomial could be something like negative 2xy squared. So there's multiple factors in there, and we even have two variables, but that is just one term because there's not any other pieces being added. Okay, next we have a binomial, and this is the word we use for a polynomial that has two terms. An example of a polynomial with two terms would be something like 3x plus 5. You're probably cluing into the pattern here, but the next one will be a trinomial, which is a polynomial that has three terms. An example of a trinomial would be 3x squared plus 2xy minus 5y squared. So that's a trinomial. There are polynomials that have 4 terms, polynomials that have 5 terms, and so on. We don't worry about giving them special names as much, so these are the ones that we focus on as far as having names based on the number of terms they have. Monomial, binomial, trinomial. Once we go beyond that, we just refer to them as a polynomial. Now that we have those words down for polynomials, there's some additional vocabulary that we need to talk about regarding polynomials. The first is the degree of a term, and the degree of a term is the value of the exponent on the variable of a term. So for example, if we have 3x squared minus 4x plus 5, the degree of the 3x squared is degree 2 because the exponent on the x is a 2. The degree on the second term here is 1. There's not an exponent there, but without an exponent, it's an exponent of 1 because there's one x being multiplied there. So the second term is degree 1. The last term there we say is degree 0. So if there's not a variable, it's degree 0. There's two ways you can think about that. First of all, we could insert an x to the 0 because that's just inserting a 1, and 5 times 1 is still 5. So we could think about it that way. You could also just think that the degree is saying how many x's are being multiplied. So when you just have a 5, how many x's are being multiplied? 0 of them. So that's the idea of the degree of a term. Now we want to look at the degree of a polynomial as a whole. The degree of a polynomial is the degree of the term with highest degree. So for example, if I had 5x minus 4x to the third plus 6x minus 5, then the term that has the highest degree is this negative 4x to the third. It's degree 3, so the degree of the polynomial is also 3. This idea of the degree of a polynomial is really important. It determines the overall behavior of what's going on with the polynomial, and the degrees of the terms are also important. Because of that, we have something that's called descending order. Let's look at that now. Descending order is basically rearranging the terms of a polynomial in order from their highest degree term to their lowest degree term. So again, descending order is arranging the terms of a polynomial from the highest degree term to the lowest degree term. For example, let's say I had something like 3 minus 4x squared plus 5x to the third minus 6x. If I wanted to put this in descending order, I would start with the highest degree. That's going to be the degree 3, so I'm going to put 5x to the third first. Next, I'm going to put minus 4x squared because that's the next highest exponent. Then I'm going to go down to minus 6x. And lastly, I put the plus 3, which is degree 0. So now our polynomial is in descending order. We're basically rearranging it in order of the exponents from highest to lowest. This is called descending order. The next and last term we need to learn is, for polynomials, is leading coefficient. Now, first I want to remind you what a coefficient is. A coefficient is the number that's the variables are being multiplied by. For example, if I have 2x to the third, then the 2 is the coefficient. So when it comes to the leading coefficient, we could say that the leading coefficient is the coefficient of the term with highest degree. For example, let's say I have the polynomial negative 4x plus 2x squared minus 5x to the third plus 6. Here my term with highest degree is the negative 5x to the third. So what that means is that my leading coefficient is the negative 5 that's with that term. Now, if I put this in descending order, what I would have is the negative 5x to the third plus 2x squared minus 4x plus 6. So once it's in descending order, what we have is that our leading coefficient is in the front. It's taking the lead. And so that terminology, leading coefficient, comes from the idea of the polynomial being in descending order. However, it does not have to be in descending order for that to be the leading coefficient. It's always the coefficient that's with the degree that with the term that has the highest degree. Now that we have that polynomial vocabulary under our belts, let's look at adding polynomials. This is actually doing something that we've already talked about doing. It's just giving it a new name. So let me throw an example up here. Alright, so what we have here are two polynomials being added. The parentheses are actually just emphasizing what our polynomials are. So our first polynomial is x squared plus 3x minus 4. Our second polynomial is 4x, that's supposed to have a square on it, 4x squared minus 6x plus 5. So the parentheses here are just saying this is one polynomial and I'm adding it to the other polynomial. In other words, it's grouping that stuff and saying think of it as one object, where here that object we're calling a polynomial. But the important thing to notice here is these parentheses are not inducing that any math be done. They're not telling us to multiply or do anything else. In other words, what we need to do on this problem is the exact same thing we would need to do even if the parentheses weren't there. So if you're thinking, well, that just means I need to combine like terms, then you're thinking exactly right. That's all we're doing when we're adding polynomials is combining like terms. So we'll add the x squareds together. That'll give me a 5x squared. And then I'll add my x's together. That's going to give me a negative 3x. And then I'll combine the constants. And that's going to give me a plus 1. And that's it. We're just combining like terms, but we're calling it adding polynomials. Now let's look at a subtraction problem so we can see what we need to do with that. It is a little bit more complicated, but not much. Alright, example 2, subtract. I kept my polynomials the same. Now we're just going to subtract them. Now here it's a little different. It's still, the parentheses are saying we're subtracting this first polynomial from this second polynomial. They're still telling us that. But one of the things we saw when simplifying algebraic expressions is that when we're subtracting a group, we have to subtract every term in that group. In other words, what we did was we treated that negative 1, that net minus, like a negative 1, and we distributed it throughout the terms in the grouping. When we do that, what we get here is the first polynomial carried down. It's not changing. I'm just writing it without the parentheses. And then for the second polynomial, I'm going to get a negative 4x squared plus a 6x minus 5. So the sign for each of the terms has switched. If they were positive, they're now negative, and if they were negative, they're now positive. So we distributed the negative, which essentially switches all of the signs that are in the parentheses of the second polynomial. But once we get that done, we're back to just combining like terms. So if I take the x squared minus the 4x squared, that gives me a negative 3x squared. Now if I take the 3x plus the 6x, then that's going to give me plus 9x. And then, lastly, I will combine my constants to get a minus 9. So that's it. My final result is negative 3x squared plus 9x minus 9. I can't combine anything else there because I don't have any like terms. So that's subtracting polynomials. So go ahead and give some of these problems a try on your own and see how you fare.